Welcome to class. Now we are going to discuss mensuration topic. In this topic already we explained some types of the dimensions. We are having 3D shapes. How can we calculate the areas and volumes, and about the surface areas, and what is the meaning of slant area, height, all those things. Now we are going to discuss some important problems. In this chapter, complete problems are depends on the formula based. If we have in our mind, we can solve each and every problem from this chapter. So I'm going to discuss some important problems here. In the mensuration, we are having the one problem from the textbook. Find the volume and surface area of a sphere of the radius. We are having 21.2.1 centimeters. So here given the pi value as 22/7. We should take, if he mentioned the pi value 22/7, we should take that only. If he mentioned 3.14, then you should take in the solvation, then you will get accurate values. So here given the radius, is 2.1 centimeters and pi is 22/7 is given. We need to find surface area of sphere and volume of sphere. So here we need to know surface area of the sphere is 4 pi r square, and the volume of sphere is 4/3 pi r cube. So if we know these conditions, we can substitute the radius value in that formula, then we can identify the surface area and the value of the sphere. These are the two formulas for the sphere to find the surface area and volume. Therefore I am taking this one as first one and I am taking this one as second one. So I am finding the first one, surface area is equal to 4 pi r square. Then 4 into, we need to take pi value as 22/7 and r square we are having 2.1 into 2.1. So square means I am writing this one 2 times, and 7 ones are 7 point you should take, and 3s are. Then we are having 4 into 22 into 0.3 into 2.1. So by multiplying these all values, we will get here 88 into 0.3 into 2.1 and 88 into, here we are having 6.3, means we should take here 0 point, you should take 63 you will get, and after multiplying this you will get 85.44 centimeter squares. So we need to take, this is the units mandatory to mention the surface areas values whenever we are finding. So why I am taking centimeter square means repeated 2 times, that's why I am taking here squares. And coming to the second formula, this is a volume of the sphere. Volume we are taking here, V is equal to 4/3 and pi r cube. Instead of pi we are taking 22/7 and r cube means 2.1 into 2.1 into 2.1. So here we need to multiply, we need to cancel, then that is our wish, and 3 ones are 3, 0.7s are 21. So 7 ones are 7.3s are 21. Here we can take, so 4 into 22 into 0.7 into 0.3 into 2.1. So after multiplying this, we will get 88 into, again we are having 7 3s are 21 point into 2.1. After multiplying these values, we will get 38.808 centimeters cubes. This is the way we can identify the surface area of the sphere and volume of the sphere. Then we are having one more problem here. This is the find the volume and total surface area of the hemisphere whose radius is 35 centimeters is given. Radius is 35 centimeters and we need to find hemisphere volume and total surface area. So volume is here we are having hemisphere, it is nothing but 2/3 pi r cube 3 pi r square. So if we know these formulas, we can identify the hemisphere total surface area and volume also. Therefore I am taking volume is equal to 2/3 into, he did not mention the pi value here, that is our wish to take the 22/7 or 3.14. So I am taking here 22/7 into R is given 35 into 35 into 35. Cube is there. That's why I am writing here 3 times. So here 7 ones are 7 fives are. It is over. And after multiplication, what will get? 22, 44 into 5 into 35 into 35 by 3. Then after calculation, we will get this value as 833 by 3 centimeters cubes. And we need to find total surface area. It is nothing but 3 pi r square. So 3 into 22 by 7 into 35 into 35, 7 ones are 7 fives are. Then we are having 66 into 5 into 35. So after multiplying this one, we will get 11,550 centimeter squares. This is the way we can find the total surface area and volume of hemisphere. Now coming to the third problem, here given two cubes, each of volume 64 centimeters cubes are joined end to end together, and find the surface area of the resulting cuboid. So he given one cube. This is the volume we are having here, 64 centimeter cubes. It is a cube, and with this volume he arranged one cuboid by taking the side of this cube. Then he formed one cuboid with the measurements of the cube. Then how he will arrange that I will show here. So in this manner he arranged that by taking the conditions. So he arranged this one in this process. So this is the one cube. Again he made one more cube. Then by joining the two cubes he formed, it is a cuboid. So this is the meaning of this question. So we need to find surface area is nothing but total surface area of the cuboid we need to find. He given volume is 64 centimeters cubes, but volume is equal to cube. We are discussing here volume is equal to a cube. Then 64 is equal to a cube. Then we can write this one as 4 cube is equal to a cube. By this we can say side of the cube is 4 centimeters. So by using this formed one cuboid, then we need to find the surface area of the cuboid. Resulting cube means this one we are taking. So here, so this is 1a, this is 1a, total should be added means then it will take as 2a we can consider. So cuboid side is equal to 2a, then it is nothing but 2a is 4, then we are forming 8 centimeters. So we need to take total surface area of cuboid is nothing but 2 of LB plus BH plus HL. We are using this condition, we can find the TSA value. 2 of length we are having 2, and here height we are having as 4 we can take. So by using this length we are having 8 into 4 plus we are having, and 4 into 4 plus, and 8 into 4 we are having, and 2 of 8 4s are 32 plus 4 4s are 16 plus 8 4s are 32. Then by adding these, then we'll get 64 plus 16 is equal to of 80, then 160 centimeters space we are having. So this is the total surface area of the required or newly arranged or resulting area of the cuboid by the using of the cube value. So we found here. So here one more problem is there. It is nothing but we need to find medicine capsule is in the space of cylinder with the two hemispheres stuck to each of its ends. If the length of the cylinder pot is 14 mm and the diameter of hemisphere is 6 mm, then find the volume of medicine capsule. So he mentioned. So with the given measurements we need to find, this is the capsule we are taking. So this is the shape we are having here. So volume of capsule we are having, it is nothing but volume of, this is the only the part of cylinder, and we are adding the, this is the one of the hemisphere we are forming here. So total two hemispheres, 2 into hemisphere volume we are taking. So therefore volume of cylinder we need to find, and volume of hemisphere we need to find. So volume of cylinder is nothing but pi r square h, and hemisphere is nothing but 2 by 3 pi r cube we are having. So using these two formulas we can find the volume of the capsule. Already given cylinder part is this one is given 14 mm, and hemisphere diameter means complete is given from here to here. So I'm writing this one. We are taking, this is the center of the hemisphere, then he mentioned this is the diameter, he given 6 mm. So given diameter is 6 mm, and height is given, this is the 14 mm for the cylinder. Therefore volume is equal pi r square we are taking. So 22 by 7, r is 6 means then we can take 3 into 3. This is the diameter, 2 times of radius, then we are taking 6 by 2, 3, and height is given 14, 7 1s are 7 2s are 22 into 9 into 2 is equal 22 into 18. So we are having here the value is so 18 2s are 36, and 6 we are taking, 36 plus 3 39 millimeters is given, millimeter squares is given, and we need to find volume of the hemisphere. We are taking 2 by 3 into 22 by 7 into radius 3 into 3 into 3, 3 will be cancelled, then we are having here 2 into 22 by 7 into 9, so 18 into 22 by 7. So therefore volume of capsule is equal to, we are substituting the values here. Instead of taking that value we are taking 396 plus here it is also 2 times, only we found only the one hemisphere, but if we are multiplying then you will get 2 hemispheres, then it is a 36 into 22 by 7 we are having. By simplifying we will get the value here, it is by converting this one as 22 by 7 the value. So again we will get 22 by 7 is the common in the both conditions. We are having the value after simplification 162, then we can take 162 pi cubic millimeters. This is the way we can identify. So after simplifying we will get again 22 by 7 only. Why? Because here we are having the 22 by 7, again we will get 22 by 7 common, then the value of 22 by 7 is nothing but pi. If we are not converting the 22 by 7 pi value, then it is easy to find the value. If you are converting the pi value as 22 by 7 also, not an issue, at last you will get 22 by 7 as a common value. Then 162 pi is the cubic millimeters of the capsule volume. In this manner we can find. Here one more problem, we are a sphere, cylinder and cone. One of the cone are the same radius and the same height. Find the ratio of their curved surface areas. So here given sphere, cylinder and cone radius are same and height also same. So we need to find ratios of sphere, cylinder and cone. Let us consider curved surface area of sphere is 4 pi r square. I am taking this one as S1, and curved surface area of cylinder is we are having 2 pi r h, then I am taking this S2, and curved surface area of cone is we are having pi r L. This is S3 we are considering. So height and radius are same for that all. So let us consider S1 is 4 pi r square is clear, and S2 is equal to pi r h is there, and S3 we are having pi r L, but we need to get the L as in terms of radius and heights. So it is L stands for slant height of the cone. So we are having a relation in between L or H, that is nothing but L square is equal to R square plus H square. Then we can take L value is equal to root of R square plus H square. So we need to substitute the value in that S3, then we will get the all the terms should be in terms of R and H. We are removing the slant height. Therefore S3 is equal to pi, or instead of L we are taking root of R square plus H square. So now the all the S1, S2, S3 are in terms of RHS only. So there is no L. So this is the way we can identify. And here we are having hemisphere, means that is having 2 times of radius. We are having hemisphere. So D is equal to 2R we can take here for hemisphere. So we can consider this one hemisphere as a height. So L is equal to the root of R square plus H square is nothing but under root of R square plus 2R square. Then we are having under root of R square plus 4R square root of 5R square. Then we can take L value as R into root 5. So we can take this one as a Stark equation. It will use in the next step. And we need to get the S1. It is nothing but 4 pi r square. Then we are having clearly, then we are going to the check the S2. It is the curved surface area of the cylinder, the 2 pi r h. Then we are converting 2 pi r h. Already we are having 2r in terms of r's we are taking. So here we are having 4 pi r square we are having. So using this we can identify. Then S3 we are having already pi rl. Then we are taking pi r square and root 5. We are having the L value already in terms of root 5 and r. Then in this manner we can take the values. Now ratios of S1 is to S2 is to S3 is nothing but 4 pi r square is to 4 pi r square is to pi r square root 5. In all cases we are having pi r square is common. So in all cases we are cancelling pi r squares all. Then we are having the terms what we are having 4 is to 4 is to root 5. So in this manner we can find the curved surface areas of the particular sphere, cylinder and cone ratios. This is the way we can find. So this total chapter is depending on the formulas. If we know each and every formula in the mensuration topic, we can solve, we will identify the each and every answer. Otherwise we are unable to find. So be clear in the formulas, keep all the points in your brain, you will get the accurate values. This is the way we can solve the mensuration problems.